very good evening, all of you. So, uh, welcome to all of you. It gives me to great pleasure to welcome you all of you for this session 3 of day 2 of our AICTE Atal Training Program, Atal FDP program, on the title of Design, Development, and Optimization of Electrical Vehicles for a Green Future. So over the past five sessions, we have gained the valuable insights into the power of uh, sustainability in the domain of the product development. So today's the sessions will focus on very relevant and rapidly evolving area like AI powered predictive maintenance of EV motors. So, is as we know, the electrical vehicle industry is transforming the future of transportation and integrating the artificial intelligence for predictive maintenance plays a crucial role in the enhancing the efficiency and performance of the electrical vehicles. So today we are truly honored to have Dr. Ramesh Singh, senior product manager at Tata Elxsi Bangalore, distinguished expert with vast experience in automotive system and AI-driven product innovation. His expertise and leadership in the field have significantly contributed to advancing intelligent solution in electrical mobility. So I request our student Anushka. So please give the brief introduction on our today's expert.
It's good evening, everyone. It's my pleasure to introduce our distinguished speaker for today, Dr. Ramesh Singh, Senior Product Manager at Tata Elxsi Bangalore, with over 25 years of experience in delivering innovative solutions in electric vehicles, renewable energy systems, and smart grids. Currently, he leads corporate product management at Tata Elxsi, driving strategic initiatives in EV motors, predictive maintenance, and sustainability focused solutions. Prior to this, as vice president at Omega Seiki Mobility, he directed high impact projects in powertrain, hydrogen EVs, and battery technology, collaborating with international partners and across Korea, France, the US, and the Japan. Dr. Singh has a strong academic and research background, having served as research associate professor at KIET Group of Institutions and held faculty positions in multiple institutes. He has designed and developed multi-phase induction machines, transformers, EV controllers, and predictive maintenance solutions, mentoring both undergraduate and graduate students to bridge education with real-world engineering applications. His technical expertise spans electric drives, EV integration, battery management, hydrogen fuel cells, and AI-powered predictive analytics, and he has presented his work at prestigious forums including Auto EV Tech Vision Summit, IISC, Thapar Institute, and NITs across India. Today, he is here to share his insights on AI powered predictive maintenance of EV motors, a topic that combines advanced technology with practical application in the rapidly growing EV industry. Please join me in giving a warm welcome to Dr. Ramesh Singh. Thank you.
Uh, Thank you so much, Anushka. Thank you so much
Thanks, Anushka.
giving the big introduction. Yeah.
Thank you, Jatin. Thank you for the
Yeah.
whole Atal team, Sri Mata Vaishno Devi, and esteemed Vice Chancellor Sir Pragati Sir, and all the distinguished faculty members and dear students. It is a privilege for me to give a technical session on EVs and adoption of AI on how motors and all these things are being nowadays ruled by era. So, with your permission, can I share my screen now?
Sure. Of course.
For factor of safety, I'll switch off my camera.
Okay. Sure.
I hope it's visible, Jatin.
Yes, sir. It's visible, sir.
Sure. So today As Anushka and Jatin have told, I am representing Tata Elxsi and in a forum where sustainability comes as a factor. So, being my expertise and having my role in different segments of EV, my topic of concentration today will be motors and the application of AI and how AI is disrupting the whole thing over here. So, electrical motors, if we think of the various kind of applications where we have right now, are they start from mining heavy equipments. The motors are used in power generations and the various utilities. The motors applications also seem to be in the process industries, in all the chemicals and all the industries of them segment. Oils and gas segments are also there. Transport and logistics are there, and the latest part is the EV sector. So these are the whole areas where electrical motors are dominantly playing their role, and they have been a spine kind of thing in each and every segment of these. So the motors are a factor which are used since long in all these areas. So everything comes with some pros and cons. So some of the challenges that we face with electrical motors are thermal stresses. With due course of time, with due course of subject to fluctuation of loads, supply fluctuations, we have some of the other thermal stresses. These thermal stresses, which not in due time taken care of, result in shorting of interturn or face to face kind of shorting and the whole loss of the whole motor. The motors are moving, having part called rotor and supported by bearings. So there is a constant wear and tear of this bearing part, which is also a kind of disadvantage because it reduces the life and also accounts to the less effectiveness or the effective efficiency of the system. With due course of time, with different kind of anomalies creeping up, the downtime costs increase, the productivities decrease, and one more thing is there when the motors are not solidly grounded at any portion, wherever they are fixed, there are chances of some vibration. So these mechanical vibrations, usually what they do, they are reflected in the operation of the motor and they result in the ineffectiveness of the whole system. So, since the motors are not new, the challenges are also not new. From the day the motors started, electrical motors, these problems were there. So, a number of maintenance approaches to counter these things have come up in the past. The earliest methods were using some corrective methods, means when the problem comes, then some corrective action was being taken care. Before that, nothing was done. Later on, some preventive maintenance started. So it was like to stop something, what we can do, some scheduled kind of maintenance scheduling was done. And the latest which we are having right now, we are in an era of prediction. We are predicting the faults in future. So prediction is based on some of the characteristics of the whole motor. You can say some of the performance indices. With the help of that, the prediction of its future state is defined. And when the future state is defined using some good algorithms and good knowledge base of motors, such kind of scenarios can be totally neglected. And the lifespan, productivity, downtime cost all can be increased. If we compare the evolution of the various maintenance approaches which we have seen in the previous slide and we compare them in the terms of cost and the degree of enhancement, we see that the corrective was having a good proportionate amount of cost in the overall life period of a motor, but the advancement was very crude, it was very in earlier stages. Next stage came with the preventive one, where the cost of the whole overall life period was considerably less as compared to the corrective one, and some level of advancement in the technology or modern technological methods were also used. And finally, coming to the predictive part, the cost portion is very less, and that is the best advanced feature which we have right now. So the I'll come up slowly with each and every aspects. So the corrective maintenance, the thing was, let the fault occur first, then we will be going to fix them. And when a motor is subjected to a downtime or some abnormal happens on it and it is not functioning normally, so there is an disruption in the whole productivity. Whatever it was encountered for, it was used for, the whole process stops, and the downtime is very high. Whereas the preventive maintenance, it was based on the scheduled one, some cyclic, after 14 days, after 2 months or 3 months or 6 months, depending upon the usage and the environmental factors. This method was there. And at that time, it was thought that when it was compared with the corrective one, it is very good, the cost is less, and the effectiveness of the system was increased. But it was not totally sufficient because still faults were happening. If you talk of some preventive maintenance methods, scheduled maintenance is one of them. So after every 3 months, let it be, your motor is subjected to an overhaul maintenance period. So in that, even if the motor parts, some of the bearings or some of the portions were working fine, they were replaced. So it was not an effective kind of solution, which we can say. The costs were high in both of these, and unnecessary parts were replaced, and it was a very much labor intensive kind of approach. Now, here comes the predictive maintenance era, where we have a number of solutions to predict the future. Predict the future means operating state of a motor. The first and the most common method is the vibration and the acoustic method. So, some vibrational sensors are being used, and they are used to pick up some kind of anomaly, and they are trying to say what kind of problem is there, and the subsequent solution may be taken care of. Next method is a temperature method, temperature analysis method, thermal method, where because of excessive load or excessive acceleration or braking, the stator or the windings get high temperature than their permissible one, and because of these, the insulation over the wire degraded, and slowly and gradually the winding in turn short and all this come up. So temperature is also one of the method through which we can check the health status of a motor. So this is another technology for the prediction. Third method is depending upon the motor current signatures. So whatever motor it is drawing some amount of current at a particular supply, and depending upon the power factor and the load conditions, some shape, or you can say some power factor of the current is there, right? The motor is operating at a particular power factor. So in this technique, only the motor current is used, and with the help of that, the health status or the future states of the motor are defined. Latest, when in the era of disruption where AI has come in picture, all these AI ML techniques are creeping up. Every day, at least more than 10 new algorithms are developed very strong, which are taking care of each and every field. So it is not the motor which is being disrupted by the AI ML technique. It is nowadays you can see Grok, Chat GPT, Perplexity, everyone. So they are changing the whole scenario of what we used to do, how we used to do. That's all. Earlier we used to go to libraries to search, read articles, journals, write something on our notebook or take printouts, photo states. Now everything is on ChatGPT and Grok or Perplexity. So likewise in motors also, all these algorithms are there. We use them, and in a very faster manner, no time we get some results. So slowly and gradually, I'll start with each vibration one, the first one, where Vibration detects the mechanical issues where some of the vibrations are there because of rotor misalignment or bearing problem, outer race, inner race. These usually catch some kind of imbalance in the rotor, looseness in the coupling, or the misalignment of the rotors. Some wireless sensors are placed on the body of the motor XYZ depending upon the topology or the control algorithm. Either one axis, two axis, or three axis XYZ sensors are placed, and remotely they can be monitored also. They provide a real-time feedback. Whatever vibration is there, that feedback through these sensors are transmitted to a centralized dashboard or a control system or a desktop, where we compute all these things and we come up with a certain kind of solution. But the disadvantage is sensors can most of the times give, or they usually give us a false positives. False positives means if the fault is not there, and even that condition also, the fault is triggered by the system. So let it be the case of a lathe machine. If it is, the coupling is not tight and some motor alignments are not properly placed, the motor starts vibrating. So usually the sensors will transmit this vibration to the dashboard or the control algorithm, and picking up these vibrations, the control will say that there is some problem. So there will be a false positive kind of scenario, which is not acceptable in the industries. Second is the acoustic analysis. Acoustic analysis detects the structural changes which are there in the bearings one. It is a non-intrusive one. We do not have to use any extra thing on the motor part. That is a good feature for that. Acoustic analysis is very sensitive. It is very precise. So whatever is in the acoustic range it is coming, it senses this and the analysis is being done. But this is very a costly issue when you have to place for a large set of motors. Suppose you are having one or two motors, then acoustic analysis will make a sense. But suppose you are having down the line 50, 100 or more than near about 800, 500 kind of motors in your system, then this becomes very costly kind of affair to go through. Temperature analysis method is the next one. So temperature analysis, when the unexpected load or load beyond the permissible limit or beyond a particular time period are being applied on a motor, the windings get heated up because I square RT is there, and these affect the insulation over the wires, which can result in short circuiting of interturn or face to face. They can also cause degradation of the bearings. So these windings and bearings are a very typical use case for the temperature analysis method. Temperature analysis, the best part is it prevents you, it helps you stop the motor from overloading. So whenever any excess load is being put beyond, suppose 125 percentage is the excess loading capacity, and suppose it crosses that, it will give you a yellow signal or red signal that the motor is overloaded. It can also show you if the temperature profile for us, depending upon the duty cycle, let it be 1 2 3 4 7 or 9. So if it is operated beyond that, then also this will give a clear picture that something is not good. You should check the control or the motor loading conditions. So in temperature analysis, we use thermal sensors for capturing these currents, and a lot of calibration has to be done when we are talking of these temperature sensors. So very normally, if I can say, if the ambient temperature and the motor temperature, if you talk of, ambient temperature goes on changing. Suppose I am using a motor in, let it be Delhi, in a season of July, and at the same time I'm using that same company make same rating motor under the same loading conditions in Bangalore. That because of the ambient temperature, the delta T is different and the heat dissipation will be different and the temperature profiles of the motors will be different. So you have to calibrate depending upon the place where it is put, the type of load where it is subjected to. So all these kind of calibrations you need to do. Suppose, for example, you talk of a EV. So EV, if it is running in Delhi in the same condition, same Tata EV is running in Bangalore, different temperature profiles. So who will do this calibration? Will a local engineer do the calibration? Obviously, certainly this can be done. But suppose someone is driving a vehicle from Bangalore to, let it be, Bombay or Jaipur. What happens then? Will every time he will go to a maintenance shop for calibration? The answer is certainly no. So this is one of the drawback for temperature kind of analysis method. The next is motor current signature analysis. Obviously, this is non-intrusive because no extra sensors are being placed. Only this current is being tackled, and depending upon the industry 4.0 or depending upon the various controllers, we already know what current is flowing in the motor, right? MCSA in short form, it can detect early faults much early than it can happen. And MCSA, some good mathematical tools like higher order mathematics, FFT, HHT, Hilbert-Wurm transform, and all these kind of algorithms come in picture, which make this MCSA very robust and very precise in working. But to work on MCSA, we need the current data, which requires high amount of computation. So this data bank or the input for the whole algorithm becomes very heavy. And since the input becomes heavy, heavy means in terms of KB, MB, so it requires larger RAM and the whole system becomes more costly and complex also, right? Depending upon the different kind of use scenarios. Now comes an era where the disruption has started, AI and machine learning. They have different predictive models. Different models are there freely available down the world. You can ask any of the uh, LLM models you can use, right? And you can choose anyone, you can customize it according to your needs, and you can go ahead. These models, best part is again that they are self-learning in that, so they can learn on their own depending upon the past input output configurations. They can give a new set of output depending upon the past inputs. They can analyze the complex data, and the whole thing is when they are analyzing this thing, the data analytics becomes somewhat typical. So it is not that AI and ML are the best kind of solution for everything. Large data sets required to be there for the whole system to be trained. So obviously we know whenever we are using any kind of AI ML technique or algorithm we are making, training is there. So what is training? A lot of input parameters are required. So for all these, we need different kind of load sets, data sets. And this is a practical kind of limitation for them also. So comparing all these, what we see, vibration analysis is detecting the mechanical faults. For electrical, it is not so good. Bearing faults also, it is very good. For thermals, it is not that much, but the cost is moderate and the complexity is moderate, and the real-time monitoring can be done. The data storage or the analysis requirements are also moderate. So it is depending upon if you are not concerned about the electrical kind of faults or some other technique and thermal issues are taken care of, then this is a very good technique to work upon. Next is acoustics. All things good, but the cost and the complexity become very high and the data storage becomes very high. Thermal monitoring, the cost is very less, but what we get these kind of scenarios outputs when fault has already started and it has come to a certain level. It's just like the case of a cancer when you are diagnosing in a stage 2 or stage 3, right? So such kind of scenarios are there with them. MCSA, it is not that much good with the mechanical kind of fault. I won't say that it is totally absent for mechanical fault detection, but for all the electrical kind of faults and all the bearing kind of faults, it is proving good. So depending upon our personal experience only, what I will say that we have been using MCSA for mechanical faults also and electrical and bearing faults also. So the only thing which is stopping the market to go through, or there is a limitation, the people who are working on that, is the high amount of data, the current data that is required. AIML, obviously they can do anything, all the kind of things, but the cost and the storage facilities are too high. So the thing is, why not combine best of two, right? Why should we concentrate with only uh, growing trees with only mangoes, or growing trees with only apples or bananas? Why don't we have a garden where we have two to trees of everyone? So that is what we are working in Tata Elxsi. We are working on motor current signature analysis, and along with that we are using AI ML techniques. So AI, basic mathematics and physics equations, governed the whole set for training the AI ML. So likewise, we are using pin kind of configuration, physics informed neural networks, to proceed further. So what are the benefits of predictive maintenance? So the first thing is the downtime is very much reduced. So the motor is at a very less period. Usually the downtime is reduced by a factor of approximately 10 to 15% of the whole downtime period. The lifespan increases. Total lifespan is increased because these big kind of jerks or anomalies which result in a fault are not happening. So the lifespan increases of the whole motor and the overall system. The maintenance costs are very less, and the reliability and the effectiveness of the whole system is increased. Now, it is not that predictive maintenance is very much goody goodies kind of thing. We have seen some of the features which are used in predictive maintenance. There are some of the challenges which need to be encountered for. High initial investment should be there. This investment should be in the form of either sensors or in the form of infrastructure, and sometimes both. Skilled workforce, highly trained people who are working or very high, having control over AIML, and persons who have good knowledge of motors. Both are required over here. So your initial this skilled workforce is a running kind of cost that is also working over there. Integration with the legacy systems is also a very big issue, because most of the systems, they have been operating with some kind of solution, and we have to integrate either whatever predictive maintenance tool we have been deployed or we have made or we want to deploy with those kind of systems to retrofit it. The data quality issues, whatever kind of sensors we are using, either it be temperature, acoustic, or MCSA, the kind of sensor should be very precise. So this again goes in the terms of cost also, because high sensor precision and all this sensitivity, they increase the cost. And with the compromise on the cost, you get inconsistent data which can reduce the model accuracy. So talking about the future, what we have been doing is certainly AI driven analytics, which we have been deploying, because some of the algorithms are already there and we have been upgrading them, we have been tuning them according to the market needs and specific purpose of applications. And depending upon these, the various kind of diagnostics and dashboards come in field. Let it be there are two drivers running same Tata EV, and depending upon the drive cycle, we will come to know that driver A is subjecting excessive acceleration and degradation, which is causing, obviously it is causing regenerative braking, but it is going to harm the motor in long. So different kind of analytics we come in we can see with the help of AI. Predictive maintenance help reduce energy waste because when the motor is obviously running in always in a best or next to best kind of health status, the losses or you can say the power factor and all this efficiency, they are very good. So the power which is drawn from the grid or supply is a very quality one, and moreover it is not injecting any kind of THD to the whole system. With the help of digital twins and IoTs, we can incorporate the whole motor, different kind of motors which are there in different field applications. We deploy them, and with the help of digital twins, we can exactly precisely predict the future status, and different kind of load applications can be done, different kind of drive cycles can be put, different kind of loading patterns can be put, and we can see on simulation, basically emulation. With the help of these emulation techniques, we can use for predicting the various kind of anomalies or the subjective anomalies which can come in place. With the help of 5G integration, obviously when we are talking of all these kind of future predictive maintenance tools, communication of data is required. So 2G, 3G, 4G, now 5G. So the data transfer and the latency period is very less. The data is being transferred at a very high speed, and it looks like real time monitoring is there, right? Exactly. It's if it is a kind of microsecond or nanosecond kind of displacement, we will say that exactly the same kind of time we are operating in. So this is the part where we are working on the integration of AI, ML, and MCSA, and most of the top researchers have been now incorporating AI in all those. It is not that AI, ML is used in MCSA also only. AI, ML is used in temperature also, vibration also, and others also. But seeing the combination, what we thought and others have also, literature has also proved, and our practical validation is also there. This combo is the best one which is working in the field of predictive maintenance, because we have been deploying in various Tata Motors, and apart from Tata also other big OEMs and tier 1 companies are there which have been using our product with this combo, which is practically giving us fault detection in a very early stage. I'll tell a realistic kind of scenario. Every Tata motor or any motor tier 1 or OEM company which have been using, we have been predicting the state to near about 500 to 800 hours before some kind of fault is going to happen or not. And specifically, not only something, what kind of fault and what level of fault, what is the degree of fault, it is mild, moderate, or severe, and by what time the certain load pattern and drive cycle continue, this will going to happen. So the early warning signals can be there. It can be either for the mechanical one or it can be for the electrical one. It can be showed on the dashboard if it is an EV, or it can be the dashboard of any fleet operator whosoever is operating at a particular distance place. If it is an industry, it can be a manager or it can be a VP engineering that can have a whole dashboard kind of thing. What kind of different motors are operating and how are they actually going through their health status. The various machine learning algorithms, they are auto tuned with the various kind of daily inputs and outputs, and obviously the program has been trained like that with the help of AI, that whatever system or we have been training system, what I'm calling is whatever the data sets we have trained, the system is daily growing, and system is slowly and gradually increasing day by day, so with the help of adaptive learning techniques only. But all these things come with high computation power and large data sets. So we have to store somewhere, and we have the processing should be very high. So here comes the communication part, like cloud. No need of any physical kind of storage things. We can go on cloud. We can have high virtual machines which can be performing these kind of computation purposes. The advanced algorithms that are being used in these kind of scenarios are LSTM, RNN, ARIMA for the precise forecasting techniques, and the trend prediction is also there. What I told, a driver A is there, a driver B is there, so we can directly pitch up that a driver A is driving pattern is not that much good, and the trend prediction is showing that a driver A will be prone to more kind of motor faults in the future. The outer layer of the whole operation is that whenever any anomaly is there, before it creeps up to a fault level, you should be able to identify. So this is how this was the whole base where it started, and we have been seeing these kind of results. But here again, the time series data are a challenge, because whatever kind of sensor you buy or place for the current also, some kind of noise is there. Signal to noise ratio may be good, but noise absence is not practically possible. So some process should be there to clean it and prepare it for the different kind of AIML and MCSA algorithms to run through. So this is the next stage where we have been working on. It is the predictive maintenance plus the prescriptive one. So it is prediction. In short, what we have been doing with various kind of AIML algorithms backed by physics equations, and we hence prescribe the different maintenance schedules. So it is earlier maintenance schedules were either fortnightly or once in 3 months. Now no dates are prescribed. Now no dates are fixed. Depending upon the algorithm outputs only, we prescribe what I told some time back, 500 hours of operation or 800 hours of operation. So the fault level will increase. It will be slightly yellow, then orangish, then become red, and it will tell that now it is a high time, you should go to maintenance shop for the repairing purpose. The automated maintenance orders are generated. It generates work order based on the predictive insights of the various algorithms. It comes on the every motor dashboard or a assembly line or in a small factory setup, or it can be in a 1,000 or 1,200 motor assembly of Tata Steel, or it can be for a Amazon kind of setup where warehouse facilities are there. So automated maintenance schedules are prescribed based on the predictive outputs. Now, depending upon the computerized maintenance management systems, all things are being streamlined because everything is now in computer. We have the whole past, we have the present, we have the future states. So depending upon the outputs from AIML, digital twins, and present IoT signals, we are able to tell which motor is going to be scheduled, and when this motor is going to be maintained, computer automatically generates a standby motor requirement is there, so that standby motor is present when this motor is going for a scheduled maintenance. But obviously, existing workflows make the whole operation very tedious, or you can say very complex. So when we started the whole work with Tata Steel, they had different kind of setups, but to convince the down the line last person who is working on motors to the top VP or the GM level, it took some time, but slowly and gradually things are coming up fine. And it's not Tata Steel only, it is Amazon, Ashok Leyland, and henceforth other companies also which are going with the similar flow. So we have been talking, sustainability is a kind of word. There are two, three words right now in the whole, you talk of technology. Whenever people sit, they do not have anything to talk of, they talk of sustainability, they talk of AIML. So this is a very common thing, just like earlier we used to talk about any while drinking tea, you talk about politics or religion, caste, everything. Now they talk of AIML, how AIML is disruption, how sustainability is going to be playing its role. So sustainability is not a topic to be discussed. It is a method of life to be preached and worked upon. So that's way how we work in our company, and that's how we proceed and tell to others also. Sustainability, when this predictive maintenance comes in picture, it is something. I give you a small example. Everyone must be either in their homes or in their hostels. They have ceiling fans, although the power rating of ceiling fans is very small, but sometimes there is a short between the windings. And what we do, we call an electrician. He takes down the fan down with his multimeter, checks the conductivity. He said, sir, motor to aapka jal gaya and it has to be repaired. So ठीक है, you take it. Now after 1 day, 2 day or whatever time, he comes back, slaps you with a money of 1200 or 1000. Sir, पूरी winding करनी पड़ी and I had to rewind the whole motor and this is the cost of copper. This is my cost and you have to pay for that. How predictive maintenance will come in picture? I gave an example of small motor only, but you can enlarge it with bigger motor. So if you know that some stator to stator interturn short circuit is going to happen some 500 hours before. So the solution is you take some varnish, whatever level of insulation was put on that motor, you just spray it on that portion, because predictive maintenance tools, AI, ML, and MCSA will give exact pointing which slot is having which kind of defect. So you can place that amount of insulation, 5, 10, 20 rupees, let it be 50, and you can just spray and the work is done. And the motor lifespan has increased. I just gave an example of 50 rupees versus 1000 rupees, 2 day versus 5 minutes. So that is how sustainability is being affected with the predictive maintenance tools. Whenever the motor is operating at a healthy state, obviously it is driving at a good power factor, good TSD level. So grid is also not at a burden. The transformer which is supplying is also not at a burden, and the cost or the bill that you are paying is also not excess. So energy optimization is also done. Energy wastage due to inefficiencies, due to wear and tear, when the ball bearings, misalignment, rotor eccentricity, all these kind of things are there. Obviously, efficiency decreases because some part of energy is there going the waste. Some sound is there or some other vibration is there. It is counting for that. But with the help of prediction, we come in advance. When mild kind of faults are only there, we can take it to the maintenance shop, get it repaired, and the things start working in an efficient manner. Overall, when material wastes are not there, energy consumption of the whole motor is very good, TSD is fine, the motor health is always running good, the lifespan increases. It is something like that. A person who is always eating healthy, a person who is using junk foods. So the lifespan or that part for a eating healthy food eating person will obviously be more. Similarly is that for a motor. And regular predictive maintenance helps early fault detects. So wherever the fault time was there or the end of life for a motor was there, we have increased it. So the residual useful life RUL is also increased with the help of predictive maintenance tools. S- Another thing is carbon footprint. So carbon footprint is another one buzzword which technical people nowadays talk about. So this was again from the example previously that I have taken of a ceiling fan. You take the whole copper winding, you throw it, and it goes to what portion of that goes for recycling and all. But if you expand that, you do not create any waste. You reuse, repair, and reuse. Then carbon footprint will be less. And this unplanned maintenance schedules, these lead to higher repair activities. But minimizing unplanned maintenance increases your lifespan and decreases your overall carbon footprint. So overall, if an industry it is accounting for cost point of view, then also predictive maintenance is coming in picture. If it is taking a viable goal of sustainability, then also this predictive maintenance tools makes a big sense. So due to initial sensor installations and the infrastructure setup, the initial carbon footprint will be more, obviously, because something extra has been put in the whole system. But the return on investment is very fast, and the overall the system starts performing in a very efficient and effective manner. So this is the final conclusion that we have been giving. Predictive maintenance, it is very crucial for all the operations of electrical motors for the all different segments that had been untold in the starting of the slides, and they transform the motor reliability and efficiency to a next level, and ultimately the cost effectiveness of the whole product. And increasing adaptability of AIML and digital technologies are making the whole scenario or the plethora of motors with AIML and predictive maintenance a good future. So this is where I'll give a stop to my presentation. And if any kind of doubts or any discussions are required, I'm there.
Thank you so much, sir. Thank you. Dear participants, if you have any questions, please you can write the questions in your question answer box. Otherwise, you can also post your questions in the WhatsApp group. I'll just- Sir, actually, we just got from the one question from participant Satyajit Sahu.
Okay.
He wants to ask that do we have skilled workforce to do this predictive maintenance perfectly?
Yeah, why not? See, in India, we have everything. If you talk of, right, in India right now, our Thai is there, right, which is giving a good challenge to WhatsApp, right. In India, all the technical brains we are having, right. You talk of AIML, you talk of motors, you talk of smart grids, you talk of biomedical, everything originated in India, and we are still having that legacy. Apart from history, we are having the presence, and we are the future, right? So, what topic you say is not there in India? Everything we are having. You talk of AIML, we are having the best things. We talk of motors, we are having the best parts. We talk of control system, you talk of instrumentation, everything we are having. Any specific thing, if you ask, then it is there. But overall, what we have been doing very good, and we will certainly do very good in future also.
Uh, Thank you. Also, we got for another questions from participant Bulla Sridhar sir. He wants to ask that where do we get data set for training and testing for maintenance other than real world data? Do we have do we have any in any website or
Now, I'll tell you, if you talk of, if you ask me a very point to point question, do you have a data from website? Certainly there are. There are IEEE journals, IEEE databases where you can take this data. There are courier journals where you can take the data. There are German journals where you can take the data. But my practical suggestion will be please work on these stored data, but please also have a practical application from a real time kind of system. Right now, all industries, whichever find any company which is near to you, approach them, do industry academia collaboration, share something. The companies will be very much willing to help if they get something in return, right? So ताली दो हाथ से नहीं बजती, तो किसी का भी प्रॉफिट दो हाथ से नहीं होगा. यू हैव टू शेयर समथिंग टू इंडस्ट्री दैट दिस इज बेनिफिशियल टू यू, एंड इफ काउंट्स टू देम, दे विल certainly be in a position to help you back. तो IEEE is there, journals, Korean journals are there, German journals are there, which certainly give you these data, right? But apart from working these data, please collaborate with some industry which is near to you. ऐसा भी नहीं कि आप यहाँ बैठे हैं and you start dealing with टामू, और टामू से आप बात कर रहे हैं कि टामू का प्रोफेसर मुझे हम ही दे तो लिया प्रोफेसर डाटा देगा. प्लीज अपने आसपास किसी को ढूंढें.
I also got one question in my WhatsApp that what kind of partnership between the AI companies and EV manufacturers are necessary for successful predictive maintenance solutions?
See, AI has now started from design. It has earlier it was just output, which I have showed. Predictive maintenance is just controlling the output, right? Now AI has come in design feature also. Now the thing is, depending upon the drive cycle load conditions, motors are redesigned. So whatever should be the winding pattern and all these kind of things, they are being used in that part also. So motor manufacturers, AI, this is the kind of thing, redesign, repurpose, refabricate, and the whole thing goes on. It starts from zero.
Um, so, dear participants, if you have any questions, please you can ask in your question answer chat box. Please. Okay. Okay, I just got another question.
Yeah, please.
How do you see the role of AI powered predictive maintenance evolving in the next 5 to 10 years in the EV industry?
It's certainly very huge and it is going to disrupt a lot. So one thing, this most of the audience is from which background, Jatin?
They
Which
are they are they are faculty members, they are industrial professionals, they are
no,
PG
no,
scholars.
from which students, let it be from which branch?
Actually, they are participants, so I don't know that
Okay,
background.
okay, fine. So the thing is, the AI is going to very dominantly rule everything, right? But the only thing is, it is a sword. You have to handle it very carefully, right? So you should know what to do with what. So this is right now everyone is doing Googling part only with AI. What will happen? So it is not that. It is certainly going in between the stages. So in between the stages when you go, so it is something like that. Very earlier, someone told me that it was datum, then data, data, information, information, knowledge, knowledge, wisdom.
Yeah,
So one who is having data is right now said to be the king of the world, because data, Google, right? Every mobile, Xiaomi, camera, WhatsApp, right? They are having the data, so they can rule the world. So that is where create your own data, right? And obviously rely on the other people and believe that this which tool to use for which data. It is not like that random forest can be used for any other thing, all the purposes. LSTM can be used for all the kind of applications, or RNN. You have to precisely with due head heavy concentration, you have to place which kind of algorithm to be used for which kind of application. But certainly the road is very big and the role is also very big, and concise decision of each and everyone will make it a smoother path for everyone.
I hope the the participant got his answer. Uh, okay, so dear participants, if you have any further questions, you can directly reach out to Dr. Ramesh Singh sir. He is also available on LinkedIn. So
Yeah, please.
yeah,
Any kind of technical discussion, I'm very happy to go through because I have been interacting with students since very long when I was directly in teaching, and after that also I'm very fond of learning, teaching. It's very good to learn, unlearn, and relearn.
Yeah.
So when you practice this thing, you should be very happy when you someone asks a question which you do not answer, which you cannot answer. That's a very good question, because then it strikes back, going back to basics, books, and whatever, now chat GPT and online journals. So discussion should be there, and discussion is only there when there are question marks.
Yeah.
When only semicolons are there, it gives a full stop and it ends the way. So always have a question mark, and question marks are always welcome from my side.
Yeah.
It's a pleasure for me to,
Yeah.
uh, if some of the participants can just turn on their camera, we can have a selfie kind of thing, since it is an
Yeah.
online kind of event. If some of them are willing to.
So actually, we have made them as a viewer only.
Oh, no one
So
can
so,
join.
so
Okay,
no one can, if
sure,
they just,
sure.
no one can disturb us. So that's why.
No issues, no issues.
Yeah.
Thanks and
That's why.
regards to everyone, and special regards to Pragati sir, if you can convey him. My best
Yeah, sure,
regards
sir.
to him.
And so thank you so much, sir.
Thank you.
So actually, Dr. Singh has provided the overview on artificial intelligence and machine learning and preventive maintenance and predictive maintenance, which maybe intelligently anticipates failure before they occur. So thereby we can minimize the downtime and also improve the system reliability. So I hope the participants have explored their knowledge on acoustic analysis, their advantages, their disadvantages, and also they got the knowledge on comparative analysis of predictive maintenance and solutions. So I hope that participants got better knowledge from these sessions. So I sincerely thankful to Dr. Ramesh Singh sir for his valuable time and expertise and thoughtful provocation for this thoughtful discussion. So we also hope that the three sessions have enriched your the participants' knowledge. So, sir, Ramesh Singh sir, thank you so much, sir. Thank you.
Thank you, everyone. Thank you, everyone. Bye.